Okay, what I'd like to do is finish up the last lecture of the class. That's on pH and POH acids and bases. Excuse me. Now, remembering from last time, we have strong, strong and weak acids, strong and weak bases. Now, the calculations we're going to be doing in this class are going to be based totally on strong acids and strong bases, where they disassociate 100%. Now, these same calculations can be done with weak acids and weak bases, but it's significantly more complex, and it doesn't lend itself to being introduced to this very well. Okay, so let's look at a typical strong acid, something like hydrochloric acid. Strong acid will disassociate 100% to hydrogen ion and chloride ion. And it is a balanced equation, so that means the coefficients are 1 to 1 to 1. A strong base like sodium hydroxide would 100% dissociate to sodium ion and hydroxide ion. And because it's balanced, it'll be 1 to 1 to 1. Now, the reason why I'm pushing this balance stuff is that frequently we're given the parameters for the whole acid and the whole base. And once we find the molarity of that, or the moles of that, we know the moles of this, and we know the moles of that. Once we know the moles of this, we know the moles of that automatically, and this automatically on a one-to-one basis. So, for example, if we start with in a hydrochloric system here in water, if we start with 1.1 moles of hydrogen chloride, then we're going to end up with 1.2 moles of H plus and 1.2 moles of chloride. Now, after we put this in water, however, this totally goes over here. So now, after it stabilizes, we have 0 moles of this and 1.2 moles here. Okay, so this totally goes this way, totally, 100%. So there's none of that left. It's all broken up. Okay, so let's do a concentration problem here. Okay, remember square brackets. Square brackets are another way of writing moles per liter. Okay, so if we have 1.2 moles of HCl and 3.1 liters of water, what is the hydrogen ion concentration, the chloride ion concentration, and the HCl concentration? Well, right away, this is going to be 0. Because it automatically all goes over. So what is the H plus and the Cl minus? Okay, so that would be okay. All right, that's going to be moles per liter, or 38 moles per liter, molarity. Now, that is the H plus concentration and the Cl minus concentration. We go one step further. If I said instead of 1.2 moles, I had 1.23 grams. We have to first convert the grams to moles. So that would look like this. All in 3.1 liters. And again, this is going to be H plus and Cl minus. Okay, so I can do that calculator here. Okay, so we're looking at 3 sig figs, which is going to be okay, 0.0109 moles per liter. Now, what is the pH of that situation? That means we're going to take the negative log of so that's 1.96. So this is the pH. If I asked you what is the pOH, remember pOH and pH are related through 14. So that means so if we know the pH or the pOH, we can then calculate the other. So the pOH is 14 minus 196. On at 1204. Now that's a typical problem. I give you grams of an acid or a base, and I ask you for pH and pOH. I might also ask you for concentrations of hydrogen ion, chloride ion, and the original acid or base. That's basically it for pH. It's convert to moles. You got to remember though that strong acids don't exist like this. It completely breaks up. Same with sodium hydroxide. In fact, let's do this problem instead of with HCl. Let's do it with sodium hydroxide is added to 267 liters of water. I want to know the pH and the pOH. Now, because we're working with a base, we have to calculate the pOH because the pH doesn't exist in a basic system, only pOH. Okay, so we're going to convert the 234 grams of NaOH to moles. And let's see what that is. Sodium is 2299. Oxygen is 16. Hydrogen is 101. And that's 40 grams per mole. Okay, and all that is over 267 liters. And let's move that way over here. Okay, so what do we have now? we're looking at. Now this is the POH now. Okay, because there's no H. So we can't do pH directly. We have to do it indirectly through 14. So POH is equal to, and what is it, 3 sig fig? So we're looking at, and then POH is going to be equal to the negative log of that. Which is 166. And then the pH is 14 minus 166. Okay, so those are typical acid and base problems. You can get a little more involved by adding 2 acids together and finding the resulting pH. And I've given you lots and lots of practice problems, lots. Those are under modules, and I strongly suggest you go through some of these because there are some of these problems on the final. Okay, and that's basically it for our quarter. Our semester. Used to working at schools of quarter system. You should be going into Chem 400 fairly well prepared. So